What is up, guys? Debug here. So we're just going to start where we left off, which was programming our tokenizer, and we're going to start with processing a number first. So if you remember before, we're going to be processing a number in a couple different formats. So we're going to have a simple integer, we're going to have doubles or floats, as you can call it. We're also going to have numbers with exponents in it, and the exponents can be for floats or they can be for a regular integer. We can also allow underscores within inside of the number. So like if you have an underscore here, you can also have an underscore behind the decimal point in the float for whatever reason if you need to do that. So first we're going to need to have a couple different variables here. These are going to be needed to be able to process our different number formats properly. So we're going to need to know whether or not we found a dot in our number, so we know it's a decimal number, whether or not an E was found, so it's an exponent in the actual number, post E sign found, we'll get to that in a little bit, and underscore OK. So the first thing we're going to need to check is we're going to need to have a while statement, of course, to make sure we're not at is end. And in there, we're going to need to do our first check to see if our current is equal to an underscore. If so, then what we need to do is we just need to say if not underscore OK, or if we're not allowed to have an underscore, or the peak. So if we peek forward and it's a dot, then we want to say illegal number format, unexpected or illegally placed underscores. And then we want to just go to start, which will just go way back up. So the reason why we did that is, let's say you had a number right here, 1, 2, 3, and then you put an underscore right before the dot. That's kind of silly, so you don't want to do that. And then also we want to make sure that we don't start our numbers with an underscore or something like that. Next, we're going to need to check to see if we have a dot. So if we pass a dot, we have our current. We're going to take that character and put it into our character stream or our string stream. We're going to say if dot found, then we're going to say illegal number format, because you can't have two dots inside of a number. We're going to say dot found is equal to true and advance. Next, we're going to need to check to see if we have a match for our exponent. So first, we're going to go and create this isMatch function. We actually have it here. We haven't created it yet. And literally all we're going to do in our isMatch function is we're going to check to see if our char A and our char B, we're going to convert it to the lower version of the char and see if they're equal. So we're passing in our current character and our E to make sure that if it is an E, then we can process the exponent. After that, we just want to say our underscore OK is equal to false, because you can't have an underscore after an E. That's kind of weird. And we pass in our current character, and then we get the next character, and then we want to check to see if we're at the end. And if we're at the end, basically, if we have a number here, we can't end the file because we need to have a number after it to tell the compiler what exponent value it is. So then we'll just complain here saying an illegal number format. After that, we just want to have a simple else if. So we want to see otherwise if it's a plus or a C and not a number, then we also want to say illegal number format, because if our number doesn't have a plus, a minus, or a number, and we've already processed it for underscores and dots and E, then it's obviously not a number, so we just want to complain and say illegal number format. And we specifically specify here, we're saying plus, minus, or a digit. And finally, after that, we just want to have our E found is equal to true, advance our character, and then continue on in this loop. Next, once we found that we have searched for an E and we've processed that exponent properly, and we have our E as found, and we're checking our current character to see is it a sign, so is it a plus or minus, and what we do is we say post E sign found, and that's the boolean I was speaking to above that basically just shows that we have a post expression sign. And basically the reason for that is we don't want to have duplicates, so once we have it once, we can't have it again, otherwise we'll complain. We just advance our character and pass that character to our string. After that, we just need to have a simple if statement that says otherwise if our number is not a dot and it's not a digit, then we want to just break out of here, because it's obviously not a number at that point, so we need a way to break out of this loop. Otherwise, we just want to have a final if statement that checks for whether or not it's a digit, and if not underscore E is found, then we want to say we can still allow underscore. And we just simply pass in our character and advance our string. And after that, after the while statement has executed properly and we've broken out of it via this if statement here, then we just want to add our token to the stream. So we add our string stream token, and we specify that it's an integer literal. We pass in our column and our line, and then we go to the start from there. Next, after that, we want to be processing strings, so we're going to have a simple else if statement. that looks for a double quote here, which is going to hold our string, so such as hello world and blah blah blah. First thing we're going to need is a simple string with our tokens left is less than 2. So if you remember, we have up here a tokens left amount, so we just take our cursor, what our current cursor is, and we subtract our len to our cursor. That'll give us our current tokens that are left, and if they're less than 2, then basically we want to say unexpected end of string, because at a minimum we still need at least one more character to contain the other end of this string value. And up until this point, if any of you guys have noticed, when I'm doing these if checks to see whether or not we've reached the end of the file, I'm kind of doing very generic basic if checks, like for instance checking the string to see if we're at the end of the file. We haven't really gotten to semantics yet to where we can specify whether or not it's okay to end the file if we don't have, let's say, these 2 brackets here, and that's the end of the file. That will be handled by the parser and semantics. After that, we're going to need to have 2 booleans, escape found and escape. And that's going to be for slashes that we find inside of our string. And after that, we're going to need to have a while statement that's going to check again if not is end, and we're going to look to see if our current character is equal to a new line. And if that's the case, then we want to say illegal string format expected the end of the string or the double quotes before end of line. Basically meaning that you can't like enter here and have a physical new line. So like if I removed that and we had a string here and the string had a new line and it continued on to the next line and then the string ended, that's kind of messy, so you don't want to allow that. Otherwise, if we run into in our string we have a escaped and we have a slash is equal to our current, and then we want to just pass that slash in, and escape found is equal to true because we have that slash, and escaped is equal to true. We just want to advance our character and continue. Then we want to have an if statement that says if we're not escaped and if the current character is equal to a double quotes, then we want to break, because in that case it doesn't matter. We're not required in our strings to have an escape symbol. Otherwise, if that's not the case, then we just want to add our current token or current character, whatever it is, inside the string to our string. Otherwise, if we've escaped, we want to do a special check here to see if our current character is not a letter and we want to put it to lower. So if you have like a in here, if you have like a slash new line with the capital N, we will allow that as well. But let's say if it's not a letter and current is not equal to a slash, so if you don't have a slash, then we want to of course complain that we have an illegal string format, and we just say text preceding the slash must be an alpha only or a slash only. Otherwise, if it passes, then we just current token in and set our escape to false. In this case, we're at the end of our loop, so then we just want to advance, and that will just advance every time this loop runs over. So that way we can keep moving forward. So after that, we just want to add some final exit code, so that way we can process our token properly. So we just want to check to see if it is in. Otherwise, if it is, then we want to create an error for an unexpected in the file. Otherwise, if that is not true, then we want to say if we haven't found an escape, and we just literally pass in our string here. Otherwise, if escape has been found, we want to process an escaped string. So we're going to create that function next. And basically what that's going to do is that's going to readjust our string so that way it has the correct characters in it. So literally all this function is going to do is we're going to pass in our string and run until we're at the end of our string. And then we want to look at our message to see if it's equal to a slash. Then we want to look at our message +1 and see if it's an N, a T, a B, a V, or something like that. And then we add in the appropriate value for our string. Otherwise, if it's just regular text, then we want to just add that correct character to our string, and then we want to return our string here. And this just basically allows, as we're processing our strings natively in our compiler, we don't have to do this conversion every time we want to use the string. We just will already have the correct conversion there that we support. So we support backslashes, line feeds, and returns, and so on in this list. That way, whenever we need to print that specific string that we pass into our code, we can just pass it along and not have to do any work. Now that we've processed a multi-character string, we're going to start processing a single character string or a char. So if you have, the single quotes and you have an A here, single quotes and a tab, or so on and so forth. So as per design, we create our string first. We check for our tokens left, see if we at least have enough tokens to process this single character here, this actual single quote, and then we're expecting there to be a character in here because this is not legal to do in our language. So you can't have a single quote, nothing, and then another single quote because there has to be a character it evaluates. Then after that, we want to advance and we want to set up our variables. So after that, we want to just have an if statement that says if we haven't escaped and our current character is equal to a slash, once we run into this, we will allow for one more character in our single quotes to be processed because we're expecting another character after that. So what we're going to do is we're going to say has character. Then we want to complain to say illegal char format. Now the reason why we're doing this is because if we have something like this, so if we have a /t/f, so if we have something like that, then we want to just make sure that have we already processed a character in this single character string? If we have, then that's not legal to do, so we want to say an illegal char literal format. And we're specifying it here, we're saying our string cannot contain more than a single character. Next, after that, we want to add our character to our string, say we found an escape, and say escaped is equal to true, and then we want to advance and continue on. Otherwise, if we haven't escaped, then what we want to do is we want to say if our current character is equal to a single quotes, then we want to break, because basically that means that you processed your first single quote, you processed your character, your first character, and then you processed another single quote after that. Otherwise, if we have a character, and basically that means that if you do like this, a single quote, a character, and then another one, it's also not allowed. So we're going to again say illegal character literal format, complaining that it cannot contain more than a single character and that we expected a single quote to end the actual single quote string. Otherwise, we want to just set our has character equal to true, so this is going to be the boolean that's going to verify that we've already processed a character, and we just want to pass that character into our string. Then finally, we want to have a if check to see if we have escaped. Then we actually want to process the character after our slash, after our backslash. The first thing we need to do is say has character is equal to true, because we're already assuming that we're going to be processing a character after the backslash because that's the only thing we approve of, or that's the only thing that we can process at this point. So first we want to see if it's a letter. We want to convert it to a lower and current, and we also want to see if it's a backslash. So if it's neither of these, so if it's not a letter and it's not a backslash, of course we want to again say illegal string format. Here we're just saying the text preceding must be alpha only. Same thing that we complained to above in the string processing. Then we want to assign our current character to our stream and say we've escaped. After that, we just want to advance just to make sure that we can continue moving forward in our tokens. And then finally, we need to have our exiting if statements to just make sure everything is processed correctly. So we're going to check for is end, unexpected in the file, same as all of above. We want to check to see if we haven't found an escape and our character string is empty, so we just want to do a sanity check just to make sure our character string is not empty and we don't have something like the two single quotes here. Then we just want to create a new error saying illegal char format, character literal cannot be empty. And don't worry if we are running into the problem of complaining about the same error more than once, because again, remember, our error management system is going to handle that very well. So if we pass the same error to it over and over again, and even though it may be in different contexts and we're just trying to do sanity checks, we're not going to have to worry about the user getting flooded with the same error unless they enable aggressive error reporting. After that, we want to just add our entity as normal. So we add our token entity, we add our string of our data, and our char literal as the type in line and column. Otherwise, if we actually have found an escape, then we just want to do the same thing here. So we want to get our escape string and say it's a char literal. Otherwise, if we processed all this, so if we processed a string and it's not a string in here with a double quotes, and if we processed a single quote and it's not a char literal, and if we've processed a number and an identifier and all the other different types of tokens that we have in our language, then we finally want to just have this be the final check that says unexpected symbol at line and column, and we just want to put our little asterisk here, set the current token converted to a string, and then have another asterisk to tell the user that we don't know what this is and we're not going to process it, and then we just go to start. And of course, we need to advance so that we don't run into a loop running forever. Next, after that, we're going to need to have a couple of different extra functions that we have. So we're going to be writing our code for our get lines, our get data, and then our free. And I've added this. This wasn't here before. As per usual, every class that we create in our compiler is going to have a free method that we just call once we're done with it. So if we go here, all we need to do is to get our lines is just return our lines of our strings. And this is going to be all the lines that our compiler processed or our tokenizer processed during its execution. After that, we're going to have a simple freeze. So we're going to just reset all of our values, free up any lists that we have, and delete any pointers that we had, and clear our tokens, of course. Next, after that, in order to get our data, we're either going to return our actual tokens or our empty string. And then finally, we have get errors. And that is literally it. That's all you need to process a tokenizer. I've seen plenty of videos on YouTube where they're using Flex and Bison, and it's very intimidating. It's not that difficult in essence, but you can just literally write your own tokenizer in all about an hour. So now that we've gotten the tokenizer out of the way, now we can actually start getting ready to pretty much write our compiler. So the first thing we're going to need to do is allow the ability to process all of these different types of arguments that we have here. So arguments to print the compiler version, show the version of it and not exit the actual program, and so on and so forth. So the first thing we're going to need to do is initialize our errors. And if you guys remember before, this function was a function inside of our error manager that literally just went through all of our different types of predefined errors and created them. So that way, when our compiler starts, it already has all these errors ready to run. So that way, whenever we need to call the error, it'll already be ready for it. After that, we're just going to need to have a simple for loop. All we're going to do is we're going to go to our length of our args, so however many args we have, and we're just going to have a function called opt, with really it's actually a defined function, which if we go to it is literally just going to do a string compare of one string to another and see if it's equal to 0. So first we're going to see if our arg is equal to an A. If it is, that's what we're going to allow for our aggressive error reporting, to which we'll then pass to our compiler to say, hey, we're actually allowing you to complain about any error that you find. Next, we're going to have a C compile. So what this is going to do is this is going to only compile our code and not generate the actual code required to run it. After that, we're going to have a -o, which is going to output the object file of our actual program. So if the user that's compiling their code does not specify the output of their object file, the name of it will be standard to out. So if you have a program called Hello World, your program will be printed as out, or the user can say -o Hello World. So one of those two options will be provided. And if we take our current index and plus it one time and see that we're greater than our args, then we just want to have a runtime error that says the output file must be after the -o option. And basically all this is going to do is output this to the console and then exit our program. Otherwise, we just want to set the out or the output name of our file to whatever it is. For -v, we want to print the version. So after this, we're going to create a couple different functions, rt_error, print version, and some of these other functions that aren't defined here. Literally -v with the capital V is going to print our version and exit our program. That's only if you want to just simply check the version of your compiler. Next we have -o, and that's going to be a flag that's going to optimize our code. Now, I got a question recently on one of my videos asking about our virtual machine that I said I was going to be creating, and his question was basically asking, do we have to create assembly code for our virtual machine? Like, do we have to write an assembler or something like that? We're not going to need to do that because our virtual machine is going to be running what's called opcodes, or instructions that we define as processor instructions, and we literally will have a big switch statement that's going to jump through all of those different types of instructions and execute them one by one. Now, another thought might be, well, if we're going to be writing our own instructions, creating our own architecture for our virtual machine in our programming language, then why would we need to have an optimized flag here? And we essentially want to have this because as we're compiling our code, there are going to be a lot of scenarios in there where we're not going to be able to discern whether or not code that the user is passing to us can be optimized in a certain way. So as we're compiling our code through our compiler, in the higher level sense, when it's just dumping instructions into an assembler to later output that data to a file, we're not going to be able to see certain flaws in our code to be able to make it faster. So what we'll have to do is we'll actually have to build an optimizer that's literally going to take our code and go through each instruction and optimize it personally. Next, we're going to need to have a function called -h or question mark, and that's going to call our help function, which is going to tell the user basically how to use the compiler. And then after that, we just want to exit. Next, we're going to have a couple of different extra flags. So we're going to have a -r or a -release, which is basically going to optimize our code, set debugging to false, and strip our code. So essentially what this will do is this will run our optimizer when the compiler is finished compiling our code. It's going to set our code to not debuggable, so we will have the ability to be able to debug our code as the programmer. And then what strip is going to do is strip is going to take all of the source code that's going to be put in our output file and basically strip all of that metadata away. Next, we're going to have a -s or strip, which is going to, again, take that metadata away. Next, we're also going to have a magic function. So this magic is not listed here in our compiler options. And basically what that is that's a little bit of an Easter egg that I added with my compiler personally. And what that does is that allows for, as a programmer, typically in every single programming language, we will have something called an include or an import or something of that sort. Java uses imports, C++ uses includes, Python uses imports, and so on. And basically in our language, if we add the compiler flag -magic, we're going to basically let all of our resources be magically resolved. So we will be able to write programs to where we no longer have to have includes or imports or know where any of our code is. We just write out what class we need to use. So if we need to use a file class, we would say file f is equal to new file and do whatever we need to do with that class there without the use of imports. Next, we're going to have a option called debug, which is another Easter egg, and that's basically going to allow us to see certain things that are happening in a compiler. So as we're tokenizing our code, we'll see our compiler tokenizing and processing each file. And then once our code fully finishes and it optimizes, we'll also be able to see the output of how much instructions did our actual compiler optimize out. Next, we're going to have show version, which is going to just print the version, print an inline, and continue, so it's not going to exit out of our program. Next, we're going to have a target. So basically what this is going to do is our programming language is going to be very much like the Java virtual machine in a sense, to where we'll be able to pass in what virtual machine we want our code to run on. Or if you can think of it like an Android application. If any of you guys have ever programmed an Android application, you have a target SDK that you will compile against that will essentially run up to that device. So this will basically do the same thing. As we're programming our virtual machine and as our virtual machine comes out with new versions, we will program it in a way that it will be backwards compatible. So if you write a new virtual machine that maybe has new instructions that can only run on that machine and you want to have your code backwards compatible, you'll be able to use this option for that. So that way you can make sure that your code will run on the correct version of Sharp properly. So first we just want to see if we can pass in an integer for our target, which will be just the build version of our actual language. So we can just set that there by using string to long. Otherwise, we just want to check to see if we have base or alpha. Base is no longer supported. I originally had built base, so if we go here to our different Sharp versions, I originally built the base version of Sharp back in 2017, but that's no longer supported anymore. I've now moved up to alpha, which is basically a higher, more complex version of Sharp that's been heavily redone. Otherwise, if we don't have either base or alpha, then we just want to say unknown target. Next, we just want to have our simple -w for allowing our warnings, -v for saying what the version of our code is, and it's not limited by numbers or underscores or anything. The name of the version of your program can be whatever you want it to. Next, we have an option called -u or unsafe, which is basically going to allow for unsafe code. So let's say you wrote a assembly statement in your actual program, you're going to need to use this function to allow for that code to run properly. And we'll actually get to what unsafe code is in a little bit of a later episode. Next, we have w-error. So what this is going to do is this is going to basically say we will allow warnings, but we also want to set our warnings as errors. So any warnings that our compiler outputs and our user encounters, that warning will then be converted to an actual error. Next, we have a pretty interesting flag here, which is going to be called error limit. So what this is going to do is this is basically going to specify what is the maximum amount of errors that our compiler can encounter before it just decides, okay, I'm done and I won't go forward anymore. And basically we need to add this because we can't have our compiler constantly complaining about errors endlessly until the end of time, because there are certain situations where if you write certain code and your compiler gets stuck inside of a loop where it can't go forward, we just want to make sure that our compiler doesn't keep complaining about the same error and the same while loop and eventually causing a crash because of out of memory exception or something like that. So basically we allow an error limit of anything greater than 0 and anything less than 100,000. So it doesn't make sense to have more than 100,000 errors. At that point, if you have that many errors, your program is completely broken. So that's the max that we will allow. Next, we want to have object dump, which is basically going to be a flag that's going to tell the compiler at the end of its compilation whether or not we want to dump out an object file of our code. Now, the reason why we want to do this is because as we're writing our programming language, we're going to be outputting hundreds, if not tens of thousands of machine instructions that are going to be doing all different types of things. And we're going to need to use this in order to make sure that our programs are outputted correctly and are compiled correctly so that way they can run properly. Next, we have a simple check to see if it's a dash. We just say invalid option because the user may have entered an option that is not allowed by our compiler. And then after we have gotten through all of this, if we've processed everything and we haven't run into any one of these dashes here, then what we do is we have a do while loop that's going to go until the end of our args, and it's going to add the file that we're going to be processing, because we're assuming that if it's not an option here, it has to be a file that we're going to process. So we're just going to add that string to our files. Now, if we run into a dash again, so like let's say, so I actually have an example here where if in our program arguments we pass in something where we say we're processing a file here. So this is actually my support library that I've been building. So if we have our file .sharp and then we encounter another dash or another option, what we do is we just go back up to args. We're just going to go back up to here and process that arg and go through the list again. And then if immediately after that argument, so like this -o option, we run into another type of file or something like that, then we go back to processing our files down here. Next, at the end of our for loop, we just want to check to see if our files is equal to 0. Then we just want to print out the help and then return. So we can't have no files past our compiler. We can't pass in a bunch of arguments and not pass any files because our compiler has to compile something in order for it to work. So that pretty much sums it up for this video of building the tokenizer. It was pretty straightforward, and in the next video, we're actually going to start getting started writing our parser. So hopefully you guys are seeing that writing a compiler isn't as difficult as it may seem initially once you start getting into the code. So hopefully you guys enjoyed the video. Definitely like and subscribe if you guys like what you saw and you want to see more. Until next time, I'll see you guys later.